Okay, ladies and gentlemen, this is Algebra 2. This is February 9th, Friday, for those of you who are absent or just want to watch because math is so awesome. Okay, we have a few students who would like to say hi. If you would like to say hi, go to the center, and I will have to focus it one side, but you're going to be sideways. Okay, so we have Dennis, we have Brandon, we have Elise. You got to get over in the center. Joel, are you not going to say hi?
I have to go the other way.
Okay. All right. Good enough. Here we go. Here we go. So, if you want to comment on a question, you may have to speak loudly so they can hear you. Okay. And I will just point to you if it is you, if you want to do it. If you don't have to do it. Okay. You use the distributive property in factoring to simplify algebraic expressions. Now we're going to evaluate functions by using a synthetic substitution. And that's why we learn synthetic division. Basically, it's the same thing. But I'll show you what you can gain from the synthetic substitution or division to get the substitution part. Determine whether a binomial is a factor of a polynomial by using synthetic substitution. Now, why? The number of college students from the United States who study abroad, that means out of the country, can be modeled by the function s of x equals all of that. It's a long thing to read. Where x is the number of years since 1993. Maybe that's when it first started, I'm not sure. Like the, where they like trade students or whatever, student exchange, yeah, foreign exchange. And S of x is the number of students in thousands. My Spanish teacher in college said that he was a foreign exchange student, and he did a lot of stuff over in Spain and Mexico and different places. Anyway, but was talking about foreign exchange students getting sick here, and our foreign exchange students going over and getting sick because they're eating foods that their bodies are not used to. That's why, like, when we went to Mexico, you have to be very careful. If you're an American, you don't drink water there. You drink bottled water. Or you can be very, very sick. My friend's mother they were out in the city, and there was nice snow cones, and they looked so yummy, and it was so hot. And she got one, not thinking water, but it's a snow cone. It's made of ice. And so she got very, very, very sick. And she ended up in the hospital. And then they had to fly her home early because she was so sick, and they had to get her to an American hospital. But also, kids coming here from other countries are not used to the preservatives that are in canned food as much. And so my Spanish teacher, he and his wife had a foreign exchange student into their home, and they got very sick eating preservatives. So it's very interesting. Just be careful if you travel. Everybody's, intestines or whatever are used to their own country. So be careful. Okay, now you can use the function to estimate the number of U.S. college students studying abroad in 2018 by evaluating the function x equals 25. Another method you can use is called synthetic substitution. And honestly, many times that's much easier than taking that number and plugging it in some hairy function. Using synthetic substitution can give you an answer maybe a little bit more easily, okay? Okay, so some of what's called new vocabulary is synthetic substitution and depressed polynomial. But I've already talked about the depressed polynomial with you guys. And synthetic substitution is just something you get from doing synthetic division, okay? Okay, now, synthetic division can be used to find the value of a function. In other words, when we divide by an r, right, in the x minus r form, that variable, that value, of what you get out as the remainder is the y value of the answer. So the x that you put in will be what you're dividing by, and your remainder will be the y. And that point will be on that graph. I think that is a really cool thing. So you can, instead of plugging 3 into the equation, you can synthetically divide, and whatever your remainder is what the y is. Okay, that's where we're going. Okay, so if we took Negative 3x squared plus 5x plus 4 and divided by x minus 3. Now here's method 1 using long division. So here's our equation, 2, 1, 0 for the exponents. We have every space filled, right? Now we're dividing by x minus 3, so we say to ourselves, what do we multiply x by to get negative 3x squared? Well, negative 3x. And then you multiply negative 3x by both of these terms, and it goes under here. Now you know Sister Killmon, she likes to put parentheses around there and put a subtraction sign out front so you don't forget what you're doing. So the first two should always go away, or you haven't done it right, correctly. So 5x minus 9x is negative 4x. Bring down the 4, and then what do you multiply x by to get negative 4x? Negative 4. So negative 4 times both of these goes under here. We're again subtracting. I love the parentheses, but they're not there. So 4 minus, not that negative, but a minus sign out here, 12 would leave you with negative 8. Negative 8 is your remainder. Okay, now if we do it synthetically, synthetic division, and we're going to divide by 3. You put in negative 3 from here, 5 goes from there, 4 is from right there. So remember, you bring down the first term, synthetic division. You can review that if you want, or look it up on YouTube to somebody else's video. So 3 times negative 3 is negative 9. Combine, and that is going to be negative 4. 3 times negative 4 goes up here. It's negative 12. Combine, and you get negative 8. Now, lovely that 3, negative 8 is a point that is on your graph of this equation right here. Okay? All right, so it says compare the remainder, negative 8, to f of 3. Either way, if you put in 3 into the equation, you get out negative 8. You can talk if you want. You can say it. Okay? Negative 8, that's right. Okay, now, it's kind of on a curve there, but notice that the value of f of 3 is the same as the remainder when the polynomial is divided by x minus 3. This illustrates the remainder theorem. That's what that's called, the remainder theorem. You're going to get out the remainder when you synthetically divide. Okay, let me see. Can I make that go up there a little bit so it might be so curvy? Okay. Now, so what they're saying, a polynomial p of x is divided by x minus r. The remainder is a constant p of r. And so if you put in p of x equals q of x times x minus r plus p of r. That is very complicated to say that your remainder is going to be the y value. Okay? All right, so in this case, x squared plus 6x plus 2 would equal what you're dividing by, x minus 4, times, what the quotient would be of that, plus what's your remainder. But your remainder is going to be your y value. This looks a little bit complicated to read. It's more easily seen when you actually work it out. Okay, so applying the remainder theorem using synthetic division to evaluate a function is called synthetic substitution. So there's nothing really new here if you know how to synthetically divide. It is just knowing that that remainder will be the y value when you plug in this x. That's all. Okay? It says, it is a convenient way to find the value of a function, especially when the degree of the polynomial is greater than 2. So when it gets real hairy, say it's a polynomial that is an exponent that's 7, the highest degree term. To work all that out, there's a lot of room for mistake. But synthetic division, even though you can still make a mistake, there's a lot less room for mistake with synthetic substitution using the division. Okay. All right, let's go up here to the top of this page. And we have f of x equals 3x to the fourth minus 2x cubed plus 5x plus 2. Find f of 4. Now, so there's two ways to do it. Method 1, method 2. Method 2 down here, they replace the x with the 4. Or you can synthetically substitute or synthetically divide by finding the substitution of 662 in the end. So we're going to take our 3, negative 2, 5, 2, 4, 3, 2. Uh-oh. What happened in between 3 and the 1? There is no, that's right, there's no x squared term, right? That's correct. So we're going to have 3, negative 2, 0, 5, and 2. Okay, everybody okay with that? Okay, we're dividing by 4 because that's what we're dividing by here, which is the same thing as doing long division by x minus 4, right? Because that's your r, is the positive 4. Okay, so then you synthetically divide. I'm not going to take the time to go through that. I think you know what to do. If you don't, come see me or give me a call and I'll walk you through that process again. Or look it up on YouTube. Synthetic division, and they'll do it for you. Okay, so the remainder that you see here is 662. Therefore, by using synthetic substitution, f of 4, meaning when you plug in a 4 for the x, you're going to get 662 for the y, or the f of x, right? Okay, and when they did it down here, they got the same thing, 662, right there. They got the answer out as 662. Okay, I would love to do those, but we don't have a lot of time today. Somebody help me, when it comes up and it says it's not recording, let me know, because I'll have to start it over again. Okay. Okay, synthetic substitution can be used in situations in which direct substitution would involve cumbersome calculations. Let's look at this one. This is an example of one of those. Okay, refer to the beginning of the lesson. How many college students will study abroad in 2018? So their extrapolation was for this year, because this book was written 5 or 6 years ago. So, ta-da! Here we are. Now, so notice how that's going to be pretty cumbersome to do, right? Or complicated. To divide by 20 years since, 20 years since, 25 years, all right? Synthetic substitution divide by x minus 20. No, they meant 25, because that was back in 1993. Oh. That was depending on what year this book was written. Okay. We are not in that year. We are in 2018. So if we wanted to do it for 2018 now, we would say how many years is it now since 1993? So we would take 2018, there we go, 2018 minus 1993, and we would get 25. Oh, we are straight up on it, right?
Wow.
Whew, next year it won't work out so good for me, but we're on it. So let's pretend it's 2018, so we subtract, and we get 25. So that's what we're going to divide by. I don't know why they said 20 there. They really meant 25. So we're going to write all of our coefficients, numeric coefficients to each term. 4, 3, 2, 1, 0. We're good. Always check that, or you're going to come up with the wrong answer, and you're going to do it 6 times and go, Sister Killmon, I can't get this. And I'm going to go, did you have all place values represented? Mm-hmm. Oh. So do that. Okay, so then bring down the 0.02. Multiply that. 25 times that goes here. 0.5. Combine like terms. Negative 0.02. Multiply times 25. That goes there. Combine like terms. 3.53 times 25. That goes there. Combine like terms again. This 25 times 88.34. And that goes there. Combine like terms. 2,286.04. So that is in, was it in millions? I think it was back from the, yes, it's millions. So you need to turn that into millions. So you're going to multiply it times 1,000 because it's in thousands. So you want 3 zeros added on. So you're going to move your decimal place over 1, 2, 3. And it's approximately, that's why they said about, 2,286,040 U.S. college students will be studying abroad. All right, turn the página. Okay, so we're over here and going up to here. Okay, now let's look at our watch out. Remember that synthetic substitution is used to divide a polynomial by x minus a. Now, I say r a lot because that's what most books say in college said to me. but it's some number. So x minus something. If the binomial is x minus a, use a. If the binomial is x plus a, use negative a. So basically, whatever in the parentheses, you're using opposite of whatever that is in there. Because it's like if you would set it equal to 0 and solve for it. What number would that be? Okay, all right, so here we go. Synthetic division below shows that the quotient of 2x to the third minus 3x squared minus 17x plus 30 and x minus 3 is 2x squared minus 9x plus 10. I've already talked about that with you, but notice that it got 0 right here. So what does that tell us about negative 3 for this equation, or polynomial? It's on the what?
On the x-axis.
On the x-axis, because y equals 0 right there. That means it's crossing the x-axis at negative 3, 0, right? So, you know, like, well, this is something different, but negative 3, 0. So that's crossing right there. If you get a 0, then you know that's where it's crossing the x-axis, okay? All right. Now, when you divide the polynomial by one of its binomial factors, the quotient is called the depressed polynomial. A depressed polynomial has a degree that is 1 less than the original, which I've already, you guys remember all of this? We've already done this. Okay, polynomial. From the result of the division and by using the remainder theorem, we can make the following statement. Okay, so we have the big polynomial, and it equals the quotient, what we have left over times what we divided, plus 0. There's 0 in the remainder. Okay, since the remainder is 0, f of negative 3 equals 0, that means that x plus 3 is a factor of this polynomial. This illustrates the factor theorem, which is a special case, the remainder theorem. Okay, let's see this in action because it's going to make more sense. So if you get out a 0, then you know that that x minus r, or x minus a, is a factor of the polynomial. And the r or the a, whichever you want to call it, is a root where it's crossing the x-axis. Okay, so let's look at an example of this, and then we'll be good to go. Okay, factoring. I don't know. Let's focus again. Okay, the factors of a polynomial do not have to be binomials. For example, factors x cubed plus x squared plus or minus x plus 15 are x plus 3 and x squared minus 2x plus 5, because that's x plus 3 factors out, but then this doesn't factor anymore. So we're at that point we're finished. Okay? You don't have to get everything down to binomials unless they go, but if they don't go, then you're finished. Okay, that's what they're saying. All right, so now determine whether x minus 5 is a factor of this polynomial. Then find the remaining factors of the polynomial. Okay, so we're going to divide by x minus 5. And so we're going to use 5 as our r, or our a, whatever you're going to put there. I'm just going to call it r because I'm going to keep saying that over and over. Okay, so we're going to put our numeric coefficients here to synthetically divide. 1, negative 7, 7, and 15. Everybody good? And so if we divide by 5, which is the factor of x minus 5, but the root of 5. Am I saying that enough that you're really hearing me? Okay, then synthetically divide. You can do that, I think. What did you get? What's our remainder?
0.
0. So we know that x minus 5 is a factor. Factor, good. But here's our depressed polynomial. Here's our numeric values of the depressed polynomial, right? So I'm going to do this. Hopefully you can see this while I'm doing it. So we have 1, negative 2, and negative 3. So if you look here, we took out a factor of x right here, right? So my depressed polynomial is going to start off with a what squared? Instead of a third, we're going to have a square of the variable, right? X squared. So this 1 is going to be the numeric coefficient. I just worded that weirdly. So x squared, then what? Yes?
-3.
You see how that worked? My depressed polynomial came from this. It's what's left over. So I know that if I multiplied this times x minus 5, because that remainder is 0, I would get this polynomial. Okay? Now what they want to see, does this factor nicely? Well, it actually does. If they wanted an actual answer, you would then have, if it doesn't factor nicely, you could use the quadratic formula. Or you could use it now if you wanted. But anyway, so I would write x minus 5 times, let's see if this factors. Are there two things that multiply together to give me x? So that's x and x. So are there two things that multiply together to give me -3 but add together to